Okay, let's prove this following result. For any sequence an of positive numbers, lim sup of nth root of an is less than or equal to lim sup of an plus 1 over an. Alright, so let's look at that. Alright, so I'm gonna let's see, here's the proof. Alright, I'm gonna let alpha be the lim sup of an plus 1 over an. Alright, then I'm gonna choose any, say, beta, right, which is greater than alpha. Right. So since the beta is strictly greater than alpha, we know that lim sup is equal to alpha. So we know that there exists some n, the natural number n, such that, right, as long as n is greater than or equal to this capital N, right, this will imply or guarantees that Cn, actually An plus 1 over An is less than or equal to this beta. Right? Because otherwise, if we cannot do that, the lim sup is going to exceed alpha, so which is a contradiction. So we have to make sure that, so we know that there's going to be some large enough n so that this ratio is less than or equal to beta. Alright? Alright, so then you can multiply both sides by an, so you're going to get this. Right, so especially let's see, an plus 1, so I'm multiplying both sides by an, right? Then since an is a positive number, so inequality, the direction stays the same, so you have beta an. In particular, this is true starting from capital N, so this means that we know that a capital N plus 1 is less than or equal to beta times a capital N. Right? And we can say the same thing about, a n plus 2, right, is less than or equal to beta times a n plus 1. But if you plug this guy in here, we know that this is going to be less than or equal to beta squared a capital N, right? So you can kind of keep on doing it. So an plus 3 would be less than or equal to beta cubed an. So in general, we know that a capital N plus k will be less than or equal to b beta k an, right? So k just the natural numbers. All right, then I'm gonna do a little bit of substitution. I'm gonna let n be capital N plus k, right? Then we can rewrite this guy as, so this guy is going to be an, right, is less than or equal to right? So beta to the k. So k, actually, you can rewrite this guy as k is equal to n minus capital N. So it's a beta to the n minus capital N times an, right? And I'm going to actually split it as, right, beta to the negative n is divided by 1 over beta to the capital N. Then you have, this is capital N, an, right? Then you have a beta to the nth power, right? So what we're going to do is we're going to take the nth root of both sides, right? Then you get nth root of an is still smaller than or equal to nth root of an over beta to the capital N. And if you take the nth root of beta to the n, so that's going to be just beta. Alright, then lastly, we can take the lim sup of, basically take the limit, so lim sup as, of this guy. So we have a lim sup of nth root of an as n approaches infinity, right, is less than, right, so you have a lim sup of this guy, right, so this is n, right, but the lim sup of any constant to the nth root of any constant, we actually proved that before. This guy is going to approach 1, right? So therefore this is equal to beta, right? So since lim sup of nth root of an is always less than or equal to beta, right, and a beta is any number bigger than alpha, so therefore we know that lim sup, since beta could be any number bigger than alpha, so we know that this guy is less than or equal to alpha, right? Remember, which is alpha is lim sup as n approaches infinity of an plus 1 over an, right? And that will prove it, this inequality. Alright, that's it. I hope that this was clear.